This is video 2 of 5, chapter 6, functions. In this video we're going to look at what happens when a function is called, the relationship between the call and the execution of the function. We're also going to look at the way that values are passed to the functions when the call is made. When a function is called by a module, the function executes while the calling module is temporarily suspended, and only after the called function completes does execution in the call module resume following the point of the call. When your program first begins to execute, the main module is called by the operating system. And the main itself can contain 0 or as many calls as you want. And here's a reminder that a function is always called by its name. So if you want to call a function, do not include the return type, because beginning a line, beginning a statement with a data type always is interpreted as a declaration of something, not the use of something. So when we make a function call, we can supply data. For right now, the data that we supply are called are values to work with. When you make a call, the values that you pass are called arguments. From the flip side, from inside the function, each value that is passed is assigned a name. So there is a variable inside the function that corresponds to each value that you pass. These variables are called parameters. So here's an example. If I have the function sum, which we declared earlier, it takes two integer values. Then from the call, when I make the call, I am passing two values, the value 4 and the value of a times b. In this case, a is 2, b is 3, so therefore I'm passing the values 4 and 6. From the side of the function, once I enter the function, the two parameters of the function, x and y, will have been initialized with the values that were passed. So in this case, the value 4, which was the first argument, has been assigned to the first parameter, x, and the value of the second parameter, y, is the value of the second argument, which in this case was a 6. So when the function begins executing, it's as if x and y have already been initialized with the values that were passed. Couple notes. A function may not require parameters at all, and when parameters are passed, or when arguments are passed, there's a correspondence between the first argument and the first parameter. They must match in data type. If for some reason an argument is passed that has a different data type than the corresponding parameter, an attempt will be made to convert the data type, either by promotion or demotion. We'll show you a picture of what a function call looks like. Suppose we have the function with this prototype. It's a void function. It returns no value. Its name is even or odd, and it takes one argument, which must be of data type int. The function definition begins with the header, and in the header we give a name to the first parameter. So the first thing that gets passed when the call is made is going to be called by the name num. So here's an example of a function call. I hope you notice the difference. A prototype looks like a declaration. It ends with a semicolon. The definition of a function begins with a header followed by a body. The call does not mention anything about data types. Notice, this mentions the return type, the type of the parameter, the type of the parameter. When you make the call, there's no mention of data types. You call the function by giving its name and supplying how many? In this case, one argument. So here's a picture of what happens. The variable val has a value of 5. When the call is made, the value 5 is assigned to the corresponding parameter of the function. In this case, it's called num. At this point, when the function executes, it executes over here, and nothing that happens to this variable has any bearing on the value of the argument that was passed. So it is impossible to change an argument when we pass the value. Now let's look at function return type. We have seen some functions have a return type void, which means they do some work but do not produce a value that is returned. So if we have a function that returns a data type, inside the body there must be a return statement. And the return statement must return something of the type that you promise. So if you promise to return an int, then the expression that you return, that you must evaluate before returning, must produce an integer. If not, some type conversion will be attempted. Okay. Now, if a function does not return a value, its return type is void, and its body does not attempt to do a return of a value. Now, whether or not a function returns a value affects the way that you call it. In the case of the function sum that we've seen, it returns an integer. So when we call it, we must call it as an expression. The right-hand side of an assignment statement, we said an expression goes there. What's an expression? Anything that delivers a value to you. We should not call this as a statement sum, because the value that get produces, as we saw in class, falls on the floor, it's lost. On the other hand, if you have a void function, the call to the void function must always be a statement. It's never an expression. It's a statement all by itself. Okay. Again, if we call a function that has multiple arguments, then the call of the function, how do we know it's a call? No data types mentioned. I am passing two values. The value of the variable height, which is going to be assigned to the parameter h. We're going to pass the value of variable weight, which is going to be assigned to parameter w. So inside the body, I'm basically going to output the value of the first argument and then the value of the second argument. And with that, let's go and take a look at some of these functions. So here's the function. In this case, we are going to notice that we have the prototype here, we have the main, and then we put the body last. Alright, we're going to call this passing it different types. I want to illustrate that type conversion occurs. If I pass, in this case, floats to the function, the floats are going to be converted to integers, etc. Okay, so let's give it a shot. Let's run this. So let's try to compare this. Running out of space here. All right. So the first call we make, we're passing it 8 and 13, and we see 8 and 13 as the outputs. The second call that we make, sorry about that. The second call is I'm passing it of two floats, and what we see is the float 4.7 has been converted to 4, 77.25 has been converted to 77. So there are type conversions or coercion that occurs when the types don't match. Right. So I think with that we will stop. I need to remind you that there are two exhibits. There are two small programs that show some of the properties that we talked about. These two programs are also in the public repository, so you can say CP status function underscore CPP, and you will see a long list of functions that illustrate the principles in the notes. And with that, we are going to stop this video.